In this lecture, we will continue our discussion on serialization. We'll then introduce the notion of algorithms. In the last lecture, we talked about some classes for serializing an object. Well, if we want to deserialize an object, we're going to need additional classes. The other two classes aren't enough. We'll need some other classes. Now, I will mention that these are going to be very similar to the ones that we used to serialize an object. The first class we need is the file input stream class. And yeah, this is pretty much the same thing as the file output stream class. The only difference is we're reading from a file instead of writing to it. So this also comes from the java.io package, and we just specify the file that we're reading from. So just like the file output stream class, we do need to include the name of the file as an argument. So let me give you an example, something like this. And this is pretty much the same example as file output stream, except we just have the word input instead of output. So the first line is going to create a reference variable to file input stream. And then the second line is going to create an object where we're going to say that we're reading from the file.bin binary file. And then we take the address of that object and we store it into fs. Now, unlike file output stream, and this is actually closer to how we handle the file reader class, if the file doesn't exist, we get an error. Specifically, we get the file not found exception, so we do need to be able to catch this. So try-catch blocks are required to make this work. And just like with all of the other classes that involve files, we do need to call the close method when we're done. We also need the object input stream class. So once again, this is just like the object output stream class, except we are going to be reading files instead of writing. So we need to get this from the java.io package, and an object of this class will take care of all the methods that involve reading stuff from a file. So this is going to read the primitive data types, it's going to read objects from some input stream, and then we can do all sorts of stuff with it. And we also need to pass an object of the file input stream class as an argument to make this work. So if we take a look at an example here, so we could create a reference variable, an object input stream reference, we'll call it OS, and then we create an object of that class, and we pass our file input stream object in here, so we'll pass fs if we use our earlier example, and then we'll store that result into OS. And then we can just call the appropriate methods for reading in specific data types from the file and put it into our program. We'll take a look at some of the object input stream methods, but what we're going to see here is they're pretty much the exact opposite of what the methods for the object output stream are. We're just reading instead of writing. And once again, this is not a complete list of methods, but these are some of the more common ones that you may end up using in programs. So we do have the read boolean method. So this is going to read and return some boolean that we've read from the file. We have a read char method, and this is going to read and return a 16-bit character. We have the read double method, and this is going to read and return a 64-bit double. We have the read int method, and this is going to read and return a 32-bit integer. And then we have the read object method, which just reads an object from object input stream, and then we're going to return that as an object. And just like with the methods from the object output stream class, all these methods are going to need the IO exception, so we have to catch that. So we will need try-catch blocks, and then we will also need to call the corresponding close method for this object when we're done with reading from the file. There is one issue with the read object method that's worth mentioning. So if you notice in the last slide that it actually returns an object. So we take the data and we have that object and it's stored in some object class. That may not be the actual correct class. So we have to typecast it in order to get the correct object type. So like for example, let's say we want to read a string. Notice that I did not mention anything about a read chars method or a read string method. That doesn't exist. So what we have to do instead is use the read object method and typecast it as a string. So we can do something like this. So notice that we have os.readObject. So that method takes care of reading a string from our file. And then in order to store it in a string variable, we need to typecast it as the string class. Now with that said, I should also mention that it is possible that we can just typecast it to any class that we want, even when it doesn't exist. we shouldn't do that. That's a bad thing, but it can happen. So that means that we have to catch a particular exception whenever we do this. Specifically, we have to catch the class not found exception. And this exception occurs where we simply typecast this to a class that does not exist. So we have to make sure that we use try-catch blocks to handle this exception. We'll now do an example of deserializing an object. So we're going to use the same binary file from the last lecture where we had the person information. So now we're just going to read the contents from the binary file, and then we'll print it just to make sure that it actually worked. What we're going to find here is that the code is almost identical to that of writing objects to a binary file. The only major difference is just we use read object instead of write object. So let's go ahead and start writing that code. I will mention that I did include the person class here. It's the exact same class from before. It does include the serializable interface, so that is being implemented. But we'll go ahead and start writing our code here. So we still need to import the java.io package. So we'll do import java space java.io.star. If I can type, that'd be good. So do public class. I'm going to call this read objects. And then we'll include our main. Alright, so we still need our try-catch block. So we're going to put the bulk of our code inside the try-catch block. So we'll do try. And then we'll go and do the same catches that we had before. So we still need to catch the file not found exception. And we'll use the stack trace again. We'll print that if we get an exception. So then we need to catch the IO exception. And there is one more thing we have to catch. Because we are reading from an object and we are going to typecast it, we do have to catch the class not found exception. And then we'll also have it print the stack trace. Okay. So now in here, we need to create our file input stream and object input stream objects. So we'll do file input stream. We'll call it FS. So do file input stream. And we need to include the file. So we'll use the people.bin file that we had from before. And then we'll create the object input stream object. We'll call it OS. And then we pass the file input stream object. So now what we need to do is we need to create reference variables of the person class. We'll do person p1. And we're going to read the first object in the binary file and store it in here. So we'll do os.read object. And we'll do the same thing for another person because we're going to read Frodo and Sam. So os.read object. Now, we do need to make sure that we typecast this to the person class because right now it's just going to be the object class. So we need to put person here. And then person in parentheses here. And then we'll go ahead and print out these two people. So we'll do out.println p1. And then println p2. And then we need to close our different our input streams. So we need to do os.close and then fs.close. That should be everything. So we create our file objects. We read the objects, store them in reference variables. We're going to print them. So let's save this. Let's compile to make sure this works. No compile errors. So now we just got to run it and cross our fingers and hope that this works. So let's run it. And it looks like it did. So we did print Frodo and Sam. So it read the object contents from the file. And then we printed it. So sure enough, this does deserialize an object.